Looking at number 1, you have a number next to parentheses, so you're supposed to multiply. If you have a fraction and you're multiplying, you want all fractions. To make 21 a fraction, simply put it over 1. I haven't changed its value, I've just changed the way it looks. Prior to multiplying, I'll see if I can reduce by a common factor. This is divisible by 7, and this is divisible by 7. Divide by 7 leaves you with 8. Divide by 7 leaves you with 3. There are no more common factors diagonally or vertically, so we're going to multiply straight across. Positive times a negative is going to be a negative. 3 times 9 and 1 times 8. This is reduced, and I don't need to write it as a mixed number. Looking at number 3, a number next to parenthesis or parenthesis next to parenthesis means to multiply. We'll be going straight across. Negative times negative is a positive. Prior to multiplying, I want to reduce by common factors. Common factor of 3, divide by 3 leaves us with 2. Divide by 3 leaves us with 3. There's a common factor of 2. Divide by 2 leaves us with 1. Divide by 2 leaves us with 4. So again, negative times negative will be a positive. 1 times 1 times 1. The numerator will just be 1. We have 3 times 4 times 13. So 3 times 4 is 12 times 13. I'll do the scratch work over here. So that's 156. Looking at number 5, to multiply with fractions, you need all fractions. So we'll have to change these mixed numbers to improper fractions. 5 times 2 is 10, plus 2 is 12. Keep your denominator. Bring down your multiplication. 3 times 3 is 9, plus 1 is 10. And keep your denominator. We have a common factor of 5. Divide by 5 leaves you with 2. Divide by 5 leaves you with 1. And a common factor of 3. Divide by 3 leaves you with 1. Divide by 3 leaves you with 4. Multiply straight across. So this gives us 8 over 1, and I don't need to write 8 over 1. Simply 8 is fine. Looking at number 7, negative divided by a negative is going to be a positive. When you divide by a fraction, you flip this and multiply. So the negative 1/10 stays as it is. Change division to multiplication. And we flip this, so we have a negative 3/7. Nothing will reduce, multiply straight across. There you go. Again, when you divide by a fraction, we'll flip this and multiply. So this first term stays as it is. So now we have 21n. Looking for common factors, first I'll focus on the coefficients. With 7 and 21, I can divide by 7, divide by 7. With the 8 and the 12, I can divide by 4 and divide by 4. Turning our attention to the variables, I'm going to divide by n and divide by n, but it's easiest to just say the n's cancel. Looking at k to the fourth, k to the fifth, whichever base has the smaller exponent is the one that's going to be canceled out. So cancel out k to the 4, subtract 4 from 5, and you're left with 1. I don't need to write the 1, it's understood. Looking at m squared and m to the third, cancel out m squared, subtract 2, you're left with 1. Make sure this looks crossed out. We've canceled everything that we can. Multiply straight across. 3 times 3 leaves us with 9. We have k to the first, m to the first. One times 2, and there's no variables left in the denominator. So here's our answer. Looking at number 11, we're going to multiply. I'm going to write up here. So I got rid of that writing. Divide by 5 leaves us with 2. Divide by 5 leaves us with 1. You have z squared and z to the third. So cancel out z squared, subtract 2 from 3, and you're left with a 1. We multiply straight across. 4z times 2 leaves us with 8z, and 1 times 1 leaves us with 1, so it's 8z over 1. I'm just going to leave it as 8z. Multiplying with fractions, we need all fractions, so we have to make these improper. 7 8/7 times 32 35 common factor of 4. Divide by 4 leaves you with 1. Divide by 4 leaves you with 2. Common factor of 7. Divide by 7 leaves you with 5. Divide by 7 leaves you with 1. And you multiply straight across. 2 times 5 gives us 10. And 1 times 1 leaves a denominator of 1, so I don't have to write it. So looking at number 15, we're supposed to add or subtract based on the combination of signs. Unlike number 11, there was no sign between the parentheses. That meant we were to multiply. Here we add or subtract depending on if the signs are the same or the signs are different. The signs are different, we're going to subtract, but we do need common denominators. The least common denominator is going to be 9. I'll keep the signs the way they are. Since this fraction already has a denominator of 9, I don't have to change anything. I simply keep that numerator. But with this fraction, to get from 3 to 9, I multiplied by 3, so I have to multiply the numerator by 3 as well. And again, 3/9 is the same as 1/3. It just looks different. Again, the signs are different. We subtract, keep the sign of the larger, and you keep the denominator. When you add or subtract fractions, you go through a lot of trouble to get a common denominator because you have to keep the common denominator. With number 17, we're going to add or subtract based on the combination of signs. Since we have a positive and a negative, we're going to subtract. The signs are different. If I have mixed numbers with fractions, I usually like to work vertically. So we have I know I'm going to subtract because the signs are different. I don't put an operation sign here, and I know my answer is positive. I would be ready to go because we have common denominators, but if you have 2, you can't take away 4. So we borrow 1 from the 6. It becomes a 5. The one that I borrowed, I have to add to this. If I'm going to add, I need common denominators. And if the value of this is a 1, the numerator has to be a 5 as well. This is a lot to look at, so I'm going to write it as 15 7/5 over 4/5. The denominator is 5. 4 from 7 leaves us with 3, and the 15 drops down. The exponent applies to the first thing it touches, which is these parentheses. So the 2 applies to the parentheses. That means we have 2 sets of parentheses, and each set of parentheses has a negative 4/7. When you multiply fractions, you go straight across. Negative times negative is positive. We'll follow the order of operations to simplify this expression. Parentheses is our first concern. -7, +9 leaves us with a 2. I'm going to bring down whatever I haven't touched. 6. I have to preserve the operation. This is 6 times whatever the result of this is. Bring down the plus, that multiplication dot. You could have done this multiplication, but I just brought everything down to be very explicit. The next concern will be multiplication or division from left to right, whichever you get to first. I'm going to say a -4 times +3 gives us a -12. You could do this multiplication, but I'll just bring everything down to be super safe. I used that negative when I was multiplying, so it stays up there, but the 5 has to come down. We'll take care of this multiplication. +6 times +2 leaves us with a +12. It's now addition or subtraction. Technically, whichever you get to first going left to right, but as long as you have one sign in front of each number, you really can do this in any order as long as you keep up with the signs. You could say -12 and +12 gives you a 0, but again, to be super safe, I'll just proceed left to right here. +5, -12 leaves us with a -7. I'll bring down my +12, and when I combine them, we're left with 5. The signs are different. We subtract and keep the sign of the larger. Again, this problem could have been done in fewer steps. I just want to caution you, if you're unsure at all, just do one step per line and bring everything down that you haven't used. Looking at number 23, parentheses are the first concern, but within parentheses, there's nothing to simplify. Exponents come next. Exponent applies to whatever it touches, so this is 12 squared. So this is 12 times 12 gives us 144. So 12 squared is 144. Here's another exponent. If you want it to be super safe, bring down everything you haven't touched. I'm going to go ahead and do this. The exponent is touching the parentheses, so you have two sets of parentheses. Each set of parentheses has a negative 12 within. Negative 12 times negative 12 is a positive 144. So the result of this is a positive. It's a positive 144. I don't need to write positive because I'll be bringing down that sign. And now I bring down everything I haven't touched. This negative 8. I've not used that negative. Plus or positive, however you want to read it. 3 times 4. Now we have one multiplication left. So positive 3 times a positive 4 leaves us with a positive 12. Bring everything down that we haven't touched. As long as you have one sign in front of each number, you can do these in any order. On the previous problem, I did show one step per line. Even here, when I said I could have canceled out the 12s, I proceeded left to right. This one, I'm going to go ahead and just cancel negative 144, positive 144. Together they give us a 0. And then we just have to worry about negative 8, positive 12 leaves us with a positive 4. Looking at 25, the fraction bar is a grouping symbol as well as the parentheses, so we'll deal with everything in the numerator and everything in the denominator, in effect, separately. So within parentheses, positive 2, positive 7 leaves us with 9. And here within parentheses, positive 3, negative 1 leaves us with 2. And now I'll bring down everything I haven't touched. Preserve this operation. It's 5 times whatever happens in the parentheses. They put a dot here, but it's not required. If you have a number next to parentheses, it means to multiply. And here we have 5. And preserve the operation, multiplication. In the numerator, we have multiplication here and here. You can do each one, and I'm going to run out of room, so I'm just going to do 5 times 9 gives us 45, and positive 5 times 4 gives us a positive 20. The denominator, 5 times 2, gives us 10. So here the signs are the same. We'll add and get 65, still over 10. And now we can reduce by a common factor of 5. Divide by 5 leaves us with 2. Divide by 5 leaves us with 13. So we end up with 13 over 2. Looking at 27, we have a complex fraction. I'm going to clean this up some, multiplying by the least common denominator, which is also the least common multiple of the denominators. So the least common multiple of 2 and 20 is 20. 20 is the smallest number that 2 will go into, that 20 will also go into. So 20 is our least common multiple. I'm going to multiply by 20 over 20. 20 over 20 is just a strange looking 1, and when you multiply by 1, you do not change the value of what you're given. Sometimes you change the way it looks. On this first one, I'll show a little more explicitly what it is. If I'm multiplying and there's a fraction involved, I want all fractions. So this numerator is really 20 over 1. The denominator is 20 over 1. I'm not usually going to write this because it gets too cluttered. And here we'll reduce before multiplying. Divide by 2 leaves you with a 1. I don't need to write it because this denominator is always going to go away. Divide by 2 leaves us with 10. So when you multiply straight across, you simply have 10. Over here, divide by 20 leaves you with 1. Divide by 20 leaves you with 1. Multiply straight across, and you have 1 times negative 7, or negative 7. I'll say real fast, if you have a problem with just one fraction and one fraction, you can solve it a different way. This would be 1/2 divided by negative 7/20. When you divide by a fraction, you flip it and multiply. Divide by 2, divide by 2, and you get negative 10/7. You're going to have situations much more complicated than this, so I strongly encourage you to learn how to clean this complex fraction up by multiplying with the least common multiple. We're going to multiply fractions. We'll see if we can reduce the coefficients. Divide by 5 leaves us with 6. Divide by 5 leaves us with 7. Divide by 2 leaves us with 10. Divide by 2 leaves 11. This is a to the first power, so cancel that out. Subtract 1 from 3, and you're left with 2. It almost slipped my attention. I could reduce by a factor of 2 here. I could have reduced by a factor of 10 at the very beginning. You can reduce vertically or diagonally. All that matters is that you reduce all common factors in order to have a simplified answer. So let's see, I'll divide by 2, leaves me with a 3. Divide by 2 leaves me with a 5. And we'll multiply straight across. So what's left standing? We have 7a to the second times 5. So that's 35a to the second. And in the denominator, simply 11 times 3. I'm going to look at 31 and 32 because it's a situation that causes a lot of confusion. The exponent applies to the first thing that it touches. So the 2 applies to the 6. This means you have 6 times 6, which gives you 36, and this negative simply comes down. With number 32, the 2 is touching the parentheses. So you have 2 sets of parentheses, and each set of parentheses has a -7. -7 times -7 is a positive 49. I'm going to do 33 and 34 because we haven't done much work with complex fractions. I'm going to clean up the numerator and clean up the denominator. I'm going to multiply by the least common multiple of 9 and 12. You turn your attention to the denominators and you find the smallest number that 12 will fit into, that 9 will also fit into. The method that usually works is just look at multiples of the biggest. So you try 12, 9 won't go in. When I say go into, I mean go into evenly with nothing left over. 12 didn't work. Try 24, 9 won't go in there. 36, 9 goes into 36, and of course 12 goes into 36. So 36 is the least common multiple. We're going to multiply by 36 over 36. So again, we're multiplying by a strange looking 1. This is multiplication. And again, the fraction bar is a grouping symbol. So this 36 has to multiply the 7/9 as well as the 2. It gets distributed to each term. So it'll be 36 times 7/9 and 36 times 2. In the denominator, we only have one term, so it'll be 36 times y over 12. So I brought everything down to show this explicitly. Again, the 36 gets distributed to each term. Here I want a fraction, so I'm going to write it as 36 over 1. But normally I'm not going to do that. It's just too much work. 36 times 2 and here 36 times y over 12. And I'll show the 1, but it's a lot of work. The whole point of doing this is to get rid of these denominators. Divide by 9 leaves you with 1. Divide by 9 leaves you with 4. Divide by 12 leaves you with 1. Divide by 12 leaves you with 3. So now I'll work sideways just to show what we have here. 4 times 7 plus 36 times 2 and here it's just 3 times y. 2872, I can combine them. Leaves us with 100 over 3y. When I show I'm multiplying by 36 over 36 and that I'm distributing it to each term, that's more than I really expect you to do. Once you figure out the least common multiple, just put a 36 next to each term and simplify. So in effect, you can go straight to this step and you don't need to bother putting that 1 there. For 34, we have a complex fraction. We need to clean up the numerator and denominator. The only denominators we have to look at are r. So r is the least common multiple. So I'll show this sort of a faster way. You just put a r next to each term. And remember, you're multiplying. Here, r cancels r, and r cancels r. You're left with 3 times r we usually write as 3r minus 4. R times 5 we usually write as 5r plus 3. That's all you can do. You cannot cancel these because they're being added or subtracted. You can only cancel terms that are being multiplied.